This video, I'm just going to review some of our different formulas that we've learned for calculating probabilities. So if you were just given probability, asked to find probability of an event, remember probability is the number of successes over the sample space. Okay, and then probability of the complement of an event is 1 minus the probability of the event, because the events have to add up to 1. The event and its complement must add up to 1. Okay, for A union B, remember this is OR, okay? This is adding the probabilities, because remember OR is more likely, but we have to subtract off any overlap. Okay, and is less likely, this is the multiplication rule, okay? So probability of A times probability of B. And remember, this kind of depends on if it's independent or dependent. This is more what it looks like if it's dependent. And then remember, probability of A given B is the probability of the intersection over the probability of B. Okay, so let's do an example here that kind of utilizes the independent and dependent. So in this scenario, we have two classes that are each sending one student on a trip to DC. The first class has 18 students and the second has 20. You're in one class and your friend is in the other class. What is the probability you both get to go? So there's two ways they could do this. Let's talk about this way first. They have the first class is hat 1 and second class is hat 2. Draw one from each. So this is independent because the hat 2 does not depend on what happens with hat 1. Now a dependent would be doing this the other way, where all students in one hat draw two names. So drawing the first name will affect drawing the second one, right? Your probability changes after one is already drawn. Drawing one out of each, those probabilities are going to be separate. So the probability that both friends go, okay, is the probability of friend 1, which we'll say is in class 1, and then times the probability of friend 2, which friend 2 will say is in class 2. So in class 1, there's 18 students, and then class 2, there is 20 students. So choosing one from each, that is our probabilities. Multiply those, and we get 0.003 when I multiply those together. So there's about a 0.3% chance that both of you will get to go if they're drawn from separate hats, one class from each hat. Now let's see how that compares to if we put all the names in one hat and draw. So if we do both friends, right? So the probability of friend 1 times the probability of friend 2, given that friend 1 has already been drawn. Okay, so in this one, friend 1 is still 1 out of the 18, or sorry, excuse me, now these have been combined, so there's 38 total students, so this is going to be 1 out of the 38, times, now that 1 has already been drawn, change this, 2, and actually I'm just going to change this to friend. Okay, so probability of one of the friends being drawn, right, there's 2 of you, so 2 out of the 38 could be drawn on that first attempt. Now, one of you getting drawn, what's the probability that then the other one does? So remember, now there's one less of you to pick from, and there's one less total in the hat. So this now is going to be about 0.0014. So this one is actually less likely to have both of you go than this one. And why is that? It is less likely because there's more combinations of students. we'll say combinations possible. Okay, and that's because, again, there's just one, in this scenario, there's just one from each class getting paired together. Here, they're all mixed together, so there's tons and tons of different combinations that can occur, which is why this one is more likely. So both are not super likely, but the two separate hats, you have a better chance. Okay, guys, that's it for the review examples. Thanks for watching.